Okay, we're now recording. Is there anything you want to ask about before we get started?
No, sir.
Any problems you want worked?
Not at the moment.
Okay. You having trouble accessing anything in the D2L?
No, sir, not yet.
Not yet. Okay. How about the, are you using the version of the ebook?
Yes, I am.
Are you having trouble finding the assignments? The 1111 people had some trouble. There's no page numbers in the ebook.
Was it for the quiz or the
practice problems?
The practice problems? I know for whenever it showed out what page it was for the quiz, it was a little bit difficult, but I mean, I still found my way around it.
Okay. Yeah, because the actual practice problems I'm assigning in the regular textbook, like for section 4.3, they're on page 388. But the ebook doesn't have that page number. But if you go to the exercises at the end of section 4.3, they perfectly match the problems. The problems are absolutely identical.
Okay. Thank you.
All
right.
Is there, so you don't have a specific problem I can work for you today?
Let me see if I can pull it up. While I try to find one, you can go ahead, because I need to see if there's a certain one.
If you notice, I'm not using the video. I'm trying to keep the file sizes down.
Yeah.
And I don't look my greatest right now at 8 in the morning anyway, so you don't see me.
All right. Let's see.
All right, well, while you're looking that up, let me just go ahead and work a couple problems just to get everybody started on section 4.3.
Yes, sir.
And then, yeah, you can show me your problem after that. So can you see my pad of paper?
Yes, I do.
Okay. So I guess we'll start on section 4.3. This is on page 388 in the regular book. It's in the exercises in the ebook. Very first homework then was problem 25, part A. It just says evaluate. It has a log to a base 2 of 2. Okay. When the base on the log matches the exponent, these undo each other. Well, what answer? Well, the answer is the exponent. Well, nothing's shown. That means it's an understood 1. So the answer is 1. When they use other bases, there is no log base 2 key or base 3 key. There's only ln on the calculator. There's ln and there's log. This is base 10. This is base E. So an ln of, say, e to the 2 is directly 2. You can punch this on the calculator and it will show it, and it doesn't matter the order you punch the keys. These are called inverse functions. You can write e to the ln of 2 and you will also get 2. And I can play this game with log. is like identical to log base 10. You can tell this on the calculator because it will be paired with 10 to the x up above it. If we want something with just a few more steps, I could try problem, say, 27a. And it has log base 6 of 36. Well, the idea is to write the 36 as a base with 6. Hopefully you know that that's 6 squared. Now these are set up to undo, and your exponent is 2. So some of these are set up to be really easy, and some of these are a little tricky. All right, did you find a problem you wanted worked?
I have not yet.
Not yet. Okay. Let's see. One that's trickier might be 29a. This is still off page 388 or in your exercises on the ebook. Log base 3 of 1 over 27. Again, cannot directly punch it. Until I show you the trick on the calculator, you can't directly punch it. You may already know the trick. They show it to you in the next section in 4.4. You got to write this with a base 3. There's a few steps to do that. Hopefully, you see, I've got my cord here. Let's see if I can, oops. Okay, does that help? Yeah, now the cord isn't in the picture. All right. Well, hopefully you know that 27 is 3 to a third. Well, I still need it directly all on one line, and this is on the bottom of a fraction. When I switch levels, powers change sign. So if I go up with it, it becomes a 3 to a negative 3. I can write this as log base 3 of 3 to the negative 3 power. Now I have exactly what I want, a log base 3, an exponent with a base of 3. They directly undo. My exponent is negative 3. So that's the kind of tricks you have to do until we show you the calculator trick. Have you found a problem you want worked?
Not yet. I'm still scrolling through detail.
Oh, okay. All right, well, I'll just keep working some. Shout out when you find it. Another tricky one is 33a. It has log base 8 of 0.25. This one is a bit tricky, but it's just a matter of, again, trying to work way back to a base 8. I don't know, it isn't obvious right at the start. So you just kind of write in things you know. For example, this is a log base 8, and 0.25 is a quarter. Hopefully you know that. So then let's see. Sometimes it isn't obvious, but I'll try log base 8. And I know that a quarter is 2 squared. Okay. God, this comes up every semester. 2 squared. Okay, let's see. log base, I can switch the level, make it 2 to the -2, but I don't have what I want. The base 8 doesn't match the base 2. Now I'm trying to see. Oh, yeah. Okay. To get to an 8, again, some of these things are really tricky. If you remember, a cube root of 8 is equal to 2. Y'all remember square roots and cube roots? A cube root is your number times itself 3 times. That gives you 8. You got 2 times 2 times 2 equals 8. So if I replace 2 with a cube root of 8, of the cube root of 8 raised to a -2 power, and a cube root is a 1/3 power. 8 to a 1/3, still raised to a -2. Now, the square root's in a half power. If you remember, square root is in a half power. Third root is a 1/3 power. I can now raise to these powers by multiplying this. Log base 8 of 8 to a -2/3 power. -2 times 1 is -2/3. And now I've achieved nirvana. The base on my log matches the base on the exponent. My answer, -2/3. There can be other ways to do this. You don't have to do these exactly the way I do them. But on the fly, that's the way I remember how to do it. So that one, yeah, is really tricky. Have you found any problems you want worked yet?
No, but I was paying attention to that one. How did you get? I'm so confused how you got to the 3 to the 8 squared or equals 2.
This third root?
Yeah.
Okay, let me start with square roots. You know that a square root of 9 is 3?
Yeah.
Square root of 16 is 4?
Mm-hmm.
And that's because you're going 3 times 3, getting 9, 4 times 4 is getting 16, right?
Yep. Yes, sir.
Okay, well, the next step up is the third root. I could do 1, but I guess I'll jump to 8. Now, that is your number multiplied 3 times that gives you 8.
Mm-hmm.
That would be 2. 2 times 2 times 2 equals 8. I'll do one more. The next even one is 27. Can you tell that'd be 3?
Mm-hmm.
3 times 3 times 3 is 27.
Gotcha. Okay, I think I see now.
You can go up to 4th roots, 5th roots, 6th roots. Generally don't, I've never seen it go above 6 roots.
Okay. Okay, I'm kind of seeing it now.
Okay, so yeah, I had to get to a base 8, I had to bring in this.
Mm-hmm.
And then I don't know if you remember, a square root is identical to a half power.
Yeah.
And a third root's identical to a 1/3 power. So that allows me then to raise to the powers by multiplying them.
Okay, gotcha.
Let me go further down the page. I'll show the next section. Problem 35. Part A. They want you to solve for x. Page here, solve for x. They have log base 4 of x equals 3. Well, you solve by undoing. So with a base 4, you literally use a base of 4. So in effect, you go 4 and you raise it to this power. And on the other side, you do exactly the same thing. Whatever you do to one side, you do to the other side. These undo, it's like punching the E and then the ln. Again, you can't punch this directly with a base 4, but you can treat it like you're punching keys, even though we're not. That leaves the x. You've undone the log base 4. On the other side, 4 to the third power is 64. 4 times 4 times 4. I'm sure you all are beyond the mistake going 4 times 3 and getting 12. So they give you a whole section of these. (37) A is pretty easy, at least for me. Taking ln of x equals 3. Okay, you're in base E. So you're going e to the ln of x is equal to e to the 3. That directly undoes. E to the 3 is a nasty decimal. Hope you all know where your E key is. Clear off. E is paired with ln. Your whole calculator is organized this way. Functions that are inverse, that undo each other, are paired on the keys. So E is second ln. And if you want to power 3, 20.0855. If you remember your number directly for E, I'll punch it. You have to raise E to the 1. The number for directly for E is 2.718. Blah, 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 if you remember that. It literally is taking 2.718, blah, 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 and raising it to a third power. All right, that's that section. Anybody, have you found your problem you want worked? Is
No,
Mr.
not yet.
What?
I'm still just scrolling through. I haven't found one yet.
Okay. I'll go down. The next one, 45, I think it's the last section, 45 and 47. Now they want you to use a calculator. This is 45 part A. See, we're still on page 388. We're in the exercises on the ebook. And they want you to use a calculator and punch log of 2. Let me compare it with 47A, where they punch ln of 5. They say to 4 places. All right, and I don't want to insult anybody's intelligence, but these are directly off the calculator. When it shows log of 2, you use your log key. You literally punch log of 2. 0.3010. 4 places. When it shows ln, natural log, we punch ln. 1.6094. Did I show that off too quick? Oops. ln 5, 1.6094, log 2, 0.3010. All All right, don't want to insult anyone's intelligence, but if it says punch LOG, use the LOG key. If it says punch LN, use the LN key. I have met people who punch LN for everything. Don't do that. Shows LOG, punch LOG. Shows LN, punch LN. That pretty much is examples out of every section from section 4.3. Have you found anything yet?
No, not yet. I'm maneuvering through the book right now.
Okay. Well, I'm going to go on and show some examples out of section 4.4 then, since we're about 20 minutes into this. And that'll, if you find anything, holler out. And otherwise, that'll pretty much finish us. So section 4.4, page 395. Or the exercises in the ebook. If you go to, in the ebook, section 4.4, the exercises at the end of the chapter, these problems are identical. First one is number 9. They want you to evaluate log 50 plus log 200. These are base 10, even though they don't show you the 10. When it's just understood, the notation LOG is base 10. You can see it on your calculator when it's paired with the 10 to the X key on the calculator. I can show you that. LOG is paired with 10 to the X. So that signals what the bases are. They generally don't take the time to write LOG with a 10. You might occasionally see it, but it's not usually. Usually they leave the 10 off. It's like leaving the second root. In other words, they could write a square root with a 2 root, but they never do. It's just understood. All right, so I have not written down the actual laws of logarithms to show this. That would be in the lectures we're not doing, but there are 3 laws of logarithms. First law, if I have a law, you just use log of n a times a b, then we get log of a add the log of b. This is supposed to be a review out of college algebra, so I don't guess I'll punch a number to prove it to you. Well, maybe I should. Let's say I have log of 5 times 3. It should be the log of 5 add the log of 3, just to give you some confidence. And I can literally punch it 5 times 3, or I can punch it log 15. Log 15. Maybe I'll just write it 5 times 3. 5 times 3. I get 1.1761, we'll say. And if I punch it log 5, add log 3, same identical answer. 1761. All right, maybe if you see that one, I won't have to punch the others to convince you. But the other one is a fraction, a divide by b. It turns out that log of a, take the log of the top and subtract log of the bottom. And the point of this is if your items are on the same level, they have positive logs, and they simply add. It doesn't matter how many in the string, a times b times c, be log a plus log b plus log c. But fractions, logs of something appearing on the bottom of a fraction are negative logs. Third law, I have log of an a to a, say, n power. I have n times the log of a. Powers are coefficients. Coefficients can be put back up as powers. So how does this apply to this one? Well, with all positive logs, it matches law 1. So on number 9, I'll rewrite it down here. Log of, add log 200. I can write that as log 50 times 200. If I go 50 times 200, since they're all positive logs, they multiply. 50 times 200 comes up 10,000. See that again. 50 times 200 is 10,000. Log of 10,000. Again, since that's a base 10, you want this to be a 10 to a power. Log of 10, I believe 10,000, you're going to be fourth power. Yeah, 4 zeros, that's fourth power. And the answer is 4. Okay, it's probably time, because they do this, they show you the calculator trick. You can find this in your ebook, but it's not on page, you don't have a page number, it's page, I'm showing page 393. It's change of base formula. Let me redo it with this change of base formula. I'll redo number 9 with this change of base. It could be punched directly. Actually, it's kind of overdone because it could be punched directly. With calculator, log, it was log 50, add log 200, right? 200. Literally, I could punch log 50, add log 200. If I don't get 4, I'll quit on the spot. There they are. Okay, they want you to do them by these, work them out by hand though. That's their directions. Let me do one that would bring in the change of base. How about a log base of this number 15? A log base 5 of the square root of 5. All right, you can work this out the way they did last section by hand. Again, a square root's in a half power. Of 5 to 1/2 power, the answer should be 1/2. Okay, which is 0.5. Let's bring in the change of base. There's no log base 5 key, so it can't be punched like number 9. Change of base says if I go log, it's going to look like gibberish, base A of a B, I can always convert to, in effect, it converts to ln. I can go ln of B and divide by ln of A. Now, with these numbers, a log base 5 of a square root of 5, that means I can punch it ln of the square root of 5. See, that's acting like my B. And the 5 is acting like my A, divided by an ln of 5. Individually, these are nasty decimals. I'm not going to write them down. But let me punch it, the whole thing as is. Clear. Ln of the square root of 5. divide by, you got to watch your parentheses, make sure they match. ln of 5. If we don't get a half, I'll quit on the spot. Enter. There it is, the decimal 0.5. Maybe I should turn that off too quick. So yes, this is the secret to doing other odd bases. It's also the secret to graphing. If we had you graph y is log base 2 of x, there is, again, no direct log base 2, you would enter ln of x, it's acting like the b here, the argument, and you divide by ln of 2. That's acting like your a, ln of a. In effect, change of base is like a scale factor. All logs can be written as ln if you scale them by whatever the log of the base you're using. And so this is the formula for graphing in any other base. Have you figured out any problems you want worked? Mr. Stoker, go ahead.
That's good.
Okay. Let me try a couple, one or two. There's 2 more sections. Let me try one out of each. These are just exercises in using the formulas. You can't, those 3 laws, you can't use the calculator because they got letters. This was still off page 395, 4.4. Oops. Further down the page, $395, tried like 23, log base 3 of an 8x. They don't put the 8x in parentheses, but that's what they mean. And they basically say to expand this with the laws. With the laws. So with everything multiplied, law 1, you're following log, I'll keep the identical base here, of an a times b, using log base 3 of a, add log base 3 of the b. So this would be a log base 3 of the 8x would go log base 3 of 8 and add the log base 3 of the x. Now they want this simplified. This one you can simplify on this term. You got to leave this one alone. And 8 is actually, it can't be simplified. It's base 3, not a base 2. I was going to say it's 2 to the 3rd. That's a base 3. So no, this one can't be simplified. Oops. Can't be simplified. You could convert this piece to a decimal by going ln of 8 divided by ln of 3, but you don't really have to do that. You try another one like 35. Log base 5 of a 3x squared over y cubed. This is going to use a combination of law 1 and law 2. Remember, if these things are over each other, the logs subtract. I'll write it out with all the steps. You take the log of the top and you subtract the log of the bottom. And now these things work. This is law 1, and then this is going to bring the power to the front. This is log base 5 of 3, add the log base 5 of x squared, subtract the log base 5 of y cubed, and now I'll bring, this can't be simplified because the 3 and 5 don't match, but I'll bring all powers to the front by law 3, add 3 log base 5 of x. I'm sorry, I jumped to the last. It's 2. My fault. 2 log base 5 of x minus 3 log base 5 of y. In the next section, they give you the expanded form and want you to put it back in this form. Since I've got this written out, I kind of show you how to do it. You put the 2 back up. Any coefficient gets put back up. And then you read the signs. If logs are positive, they multiply on the same level. So in other words, go backwards. You have log base 5 of 3 add log base 5 of x squared, because you'd put the 2 back up. Subtract log base 5 of y cubed. And then any positive logs stay together. 3x squared. Any negative log appears on the bottom. Okay, this is what they want you to do. The problem directly finishes there, but they want you to do this, start with this and get back to this in the next section. Let me do a fresh one. Page 395. Try 51. Twice log x minus 3 log of x plus 1. And they want you to combine. So any coefficient goes up as a power. You'd write this as log x squared, subtract log 1 cubed. If that were positive, it would stay on the same level, but it's negative, it's on the bottom. Negative on bottom. So it writes as log, keep the x squared since it's positive on top. Put the x plus 1 cubed on bottom. So in effect, you're using the laws backwards. And they give you a whole section of those. Questions about this? I can't remember if I had you do something like 59 or not, but that's just an exercise in change of base. They want you to approximate log base 2 of 5. So you'd write that as log base 2 of 5, ln of 5 divided by ln of 2. And you'd have to reach for a calculator. Ln of 5 divided by ln of 2, 2.3219. Oops. 3219. That's pretty much problems out of every section for this week. Next Zoom session is scheduled for Thursday at 8, and I can, if anybody's looked at all the homework by then, I can help you out with any of the problems. Did you ever find anything to ask about?
No, sir, you explained it all to me. Thank you.
Okay, well, sure thing. I guess we can go ahead and end the session then?
All right, thank you.
Sure thing. No problem. Appreciate you coming out.
All right, thank you.